Good evening, everyone. Thank you so much for joining us today with another webinar series with ISC2 Ireland chapter. So first of all, I would like to say a disclaimer. So this session will be a recorded session and we'll be live on LinkedIn as well as YouTube as well. Having said that, so today, our guest speaker will be Dr. Madhusanka Liyanage, and our topic will be inside 5G security, protecting virtualized, distributed, and softwarized networks. We are thrilled to announce an insightful webinar on 5G security presented by Dr. Madhusanka Liyanage, a globally recognized expert in cybersecurity and network security. Dr. Liyanage is an associate professor at University College Dublin, Ireland, and a Senior IEEE Member and internationally celebrated researcher. I would like to welcome all the ISACA members as well for this webinar series. Thank you so much for joining with us today, all the ISACA members. Dr. Liyanage, over to you.
Okay, thank you very much for introduction and also giving the opportunity to present this webinar. So today I'm going to talk about the 5G security, especially the attacks relevant to this 5G security domain, because when we move for the 5G, it's like the 5th generation mobile network, we did like a radical change in the architecture. So when we are moving from 4G to 5G. So I'm going to talk a little bit about like what are the new security issues arising with this architectural change and how these new features can help us to improve the security in the telecommunication network. So this is the outline. So I hope like not many of you have a big background on the 5G domain. So I will start with the introduction for the 5G. And then I will go through the 5G security under 4 topics. The pre-5G security issues, security impact of the network softwarization in 5G, and the security issues related to the new technology introduced in 5G, and like the security issues related to the new verticals which are introduced by the 5G. Finally, I will discuss a little bit about how this network softwarization concept introduced in 5G can help us to improve the security. So let's start with the introduction to the 5G. So 5G is basically the 5th generation of mobile network. That means the mobile network has been evolved through 4 other.
Sorry, Madhusanka, will you be able to share the screen?
Sorry, I think I haven't shared the screen. Okay, sorry. I think, yeah, can you see it now?
Yes, we can see. If you can change the presentation mode, that'll be great. Yeah.
Yes. So I will be moving to the introduction to the 5G. So the 5G is the 5th generation of mobile network. That basically means like we have evolved through 4 other mobile generations. So actually, the very first mobile generation was introduced back in 1980. So this is the very first time we have the mobile network, and this time it was analog communication. The analog communication is not well secured because you can't use any of the existing encryption algorithm on top of the first generation mobile network. So basically, it was like a not so great technology, and then we moved towards the 2nd generation mobile network where we introduced the digital communication. And also, this is the first time we had the very first data services over the mobile network. So the data services means the SMS. So it was introduced back in 1990. And the real benefit of mobile network came with the introduction of the mobile internet. It was happened with the 3G mobile network, or the 3rd generation mobile network, which was introduced in 2001. And this time we were able to share some videos and photos via the mobile network, but it got further improved with the 4th generation mobile network. I think that's what make the difference. Like a lot of people move towards this mobile internet with the popularity of the 4th generation mobile network. It provides like faster and better communication. So we were able to use the mobile phones to stream videos, upload the videos. So a lot of things happen with the availability of the 4G network. So what we are expecting in the 5G. So the 5G is going to further enhance these capabilities, but I would say it's not just a mobile network, it is going to be a complex ecosystem. Why I'm saying that? Because the 5G is not only going to connect the mobile devices, but also connect the Internet of Things or IoT devices. So this is like one of the major steps we are expecting in 5G to expand the connectivity platform beyond the mobile network to the IoT domain. So when you have the ability to connect the IoT devices directly to the 5G network, it will allow us to provide the services for multiple domains, not just the mobile users, but also other critical infrastructure. It can be smart parking or smart mobility, e-healthcare, or even the critical national infrastructure like smart grid. All of these things can now use the 5G to interconnect and share the data between the different entities. So when we look at the penetration of 5G, so it is expecting the 5G is going to have like 1.3 trillion USD by 2023, and it is going to applicable almost all the segment of the human life. It going from the energy sector, manufacturing, public safety, healthcare, public transportation, automobile, retail, agriculture, you name it. Like any scenario, the 5G is going to use. The main reason it is go beyond the mobile network, providing the mobile devices, providing the connectivity for the IoT devices. Not only that, 5G is expecting to provide a lot of new applications which are not possible in the 4G network. So one of these applications is the autonomous driving cars. So autonomous driving cars it's not no longer like a fantasy like we can see like it is already available, but the cost of autonomous driving cars is very expensive. With the 5G, we can reduce the cost of these autonomous driving cars, offloading the computation function into the mobile network. And also the drone-based communication, providing the connectivity via 5G, we can expand the distance, we can control the drone, because most of the time you need line of sight communication with the drones to control, but with the 5G we can go beyond that. And then we are going for more and more better quality video streaming. We can try like 4K, 8K videos over the 5G network, hologram TV, and augmented reality and mixed reality application, because this is something very interesting. A lot of people are using in this augmented reality application, but it is not possible to run any of these augmented reality or mixed reality application over 4G network if you need the processing from the network, because the latency of the 4G network is not applicable for these applications. And the remote surgery, so the remote surgery is also not a new concept. It was available for 20 years time, but one of the limitation is the connectivity problem. So we have higher latency that make it impossible to implement the remote surgery over the existing mobile network. And industrial IoT, wearable devices, this kind of application can be enabled with the 5G. And I have very nice video. Actually, we can see like the answer. Like a lot of people are asking like why we need 5G. So 4G can do everything. Like you don't see like a real difference like or real need of 5G, because you are able to do almost everything with the 4G into day-to-day life. But the thing is like if you think about the future, like what is happening and what is you are going to enable in a coming year, 4G is not definitely going to be successful. So this is like a one good video I found to show the what is the difference between the 4G and 5G. I'm not. Let me check whether I can play it from here. Can you give me 1 second? I think it's not loading from here. I can directly share from the YouTube. So idea here is like, so they are trying to run this augmented reality application over 5G and 6G. What they are doing is like there's a camera on every player. So they will be playing football. So the video will be captured from the camera and it will be sent it to the server for the processing. After that, that processed video will be transferred back to the virtual reality glass. So they will be checking like how much this latency will be impact on the real-time application. So I think you got the idea like here, like in in uh, in the real world, you might see like in the current world, you might see, okay, the 4G is enough to do everything. But when you think about like upcoming application or something, the 4G is not really good enough. So this is why we are moving toward like the new generation of mobile network. So what the 5G will be bring. So this is the best lot of question, a lot of people asking like how 5G will be different from the 4G network. So here actually I've tried to show like what is the difference between the 4G and 5G, like what are the expectation. So as for today, I think you might using 5G, but you might not experiencing all the capabilities of 5G. But in coming years, we are expecting to have this level of capability. So one of the things we found is like in 4G, actually the maximum data rate we can support is 1 gigabit per second. So actually that was the expectation. In reality, we support only 400 megabit per second. So in 5G, we are going to extend it to up to 20 gigabit per second. And the user experience data rate, that is like the minimum you will be receiving, it will be like 100 megabit per second. And also it will be supporting faster mobility scenarios. For example, if you are using 4G in the high-speed train in France, you will be disconnected because it doesn't work beyond the 350 kilometers per hour. But in 5G, you can have that. And in 4G, actually, we were trying to achieve 10 millisecond latency, but reality, we achieve only 20 milliseconds. In 5G, we are going to reduce it to 1 millisecond. So you saw in the video, we already achieved the 1 millisecond latency. That help us to have this kind of communication. So you can see like the 5G is going to expand the capabilities. And also here, there are like the most important thing is like this energy efficiency, because we are trying to reduce the energy efficiency 100 times because we can have support for the Internet of Things. You know, IoT devices doesn't have a lot of power. So we want to have a better energy profile for them. So this is also like one of the requirement in order to support the IoT. So then actually, before I move into the security part, I want to say like the 6G network has like the 5G network or any mobile network has two main components. So one is the radio access network. So that I think that's the most people realize, because you have the base station and you have the wireless communication from the mobile device to the base station. We call it as a radio access network. So that's actually playing a huge role in enabling the wireless communication. But beyond that, we have a core network. So the core network is doing all the controlling functionalities of the network. Usually the core network is a wired network, which has like the optical fiber communication or sometimes the microwave communication, but most of the time it's the wired communication. It doesn't have a lot of wireless part, but the core network is important to manage the whole network. In today's lecture, actually, I will be talking more about this on network side rather than the radio access network, because this is where the most of the innovation happened and also the security got improved. So when we look at the enabling technologies, like how we can achieve this new requirement in the 5G, actually we have adding a new technology for the both core network and also for the radio access network. So this is just to completeness of this lecture. I added some of the enabling technologies related to the radio access network. These are like the new spectrum. We are going to use a new radio spectrum that can provide the additional bandwidth. And also we are going to use this massive MIMO techniques. The idea is like we, instead of using a single antenna in the mobile phone, we will be using array of antennas. So then you can have like better connectivity. Instead of one stream, you can have like multiple stream into the your device, so you can have better speed and better bandwidth. And also you can provide the flexible frame design. It will help you to have better information delivery within one frame or one byte of data. And then we are going for like multiple connectivity, like the mobile device will be connected to multiple networks simultaneously. And also we go for the distributed architecture. That means in order to reduce the latency, we go for the distributed architecture, because there are some limitation in the physical limitation. The communication is struggling. So I will explain a little bit in later. So in order to tackle this physical limitation, we are going for this distributed architecture in the radio network. But the changes in the radio network is not enough to have the improvement in the network. So we need to do in the core network as well. In the core network, actually, we had a very big change from we have seen so far from the previous 4 generations. So if you look at the previous 4 mobile generation, actually we had like a hardware-based core network. So the whole core network, we have separate entities, and they are built as a separate hardware unit. So this is what we saw from first generation to the 4th generation. But when it go to the 5G network, we realize this hardware-based architecture is not going to work. So instead of this hardware-based architecture, we moved for cloud-based architecture. So in the cloud-based architecture, we don't have a dedicated hardware anymore. Instead of that, we have like a hardware pool. Using this hardware pool, we can create the virtual machines. On top of the virtual machine, we can deploy any of the control function we can see in the we required in the 5G core network. So this is a very big change. Instead of having a dedicated hardware we had in the previous generation, now we have a cloud-based architecture, and also it is software controllable network. So this change from this hardware-based system to the fully software-based system, we call it as a network softwarization. It means we use the software controllable network in the 5G. So this architecture change is very big, and it has an impact on improving the services, and also it has an impact in the security aspect. So how we achieve this? Yes.
Sorry, just a quick one. Sorry to cut you short there. Anesh did mention that we have quite a number of ISACA members joining us today. There is a form on chat for you to fill in your CPE hours, and we'll send this on to our ISACA Ireland chapter to submit your CPEs. That goes the same for ISC2 members joining us today. But the point why I was just asking for a minute from you, Madhu, is that I'd like to recognize Everett here, who we have been working with closely in bringing to you these webinars, both from IC2 and ISACA. And if you're to, because he's stepping out in a few minutes, I'll just like to ask him to say a word or two, and then we can continue.
Okay.
Hi, Everett, are you there? I think if you're speaking, you're on mute. Oh, I have enabled.
It's now working. Yeah, thanks very much. On behalf of certainly SAC Ireland chapter, very pleased that we can team up with ISC squared chapter. More people attending. It's like CPs have been captured, so thank you. And myself and Cliff, brief sort of discussion about moving forward to 2026, maybe some sort of a joint physical event of some description. So the ambitions are to get it done. Just have to get it done. So thanks, Cliff.
Thank you, Everett. Have a good evening. That's it from me, Madhusanka. Back to you.
Okay. Yeah. Okay. So yeah. So the question is like how we can enable this softwareized network. So in this domain, actually, we have introduced 4 new technologies. So software-defined networking, network function virtualization, multi-access edge computing, and network slicing. So these are, I would say, like the pillars of 5G network. This enabled us to have this network softwareization in the 5G network. So then I will. So that's basically about 5G and what is the new thing we are bringing in 5G. Now I'm going to discuss about the security issues related to that. So in the 5G, actually, the security has also evolved. If we consider about the mobile network, the security has also evolved through the each generation of mobile network. So I already mentioned in the first generation, we had the analog communication. Basically, no encryption was used in first generation. So that means eavesdropping attack was easily possible. And the second generation, the biggest attack we were trying to tackling is the rogue base station attack, like the fake base station attack. When it comes to the 3G, the biggest challenge we were facing is the malicious application, because we first time we connect the internet with the mobile network, so the mobile devices were vulnerable for virus, spyware, and malicious application. And when it comes to the 4G, the biggest issue we are facing is the mobile attack, because the mobile devices have a lot of capabilities, and a lot of attacks came from the mobile devices, like advanced persistent attack, denial of service attack, or DDoS attack. So those will become a very big problem in the 4G network. So what will be the biggest problem in the 5G? When it comes to the 5G, actually, we are expecting a lot of attack can be originated with the IoT devices. So attacking these IoT devices now maybe lead to even like the cyber warfare, like because you can jeopardize the operation of the critical infrastructure. So this can be the biggest threat we need to tackle in the 5G network. So the composition of this 5G security, actually we can divide into four categories: pre-5G security issues related to the network softwarization, and the security issues related to the new technologies, and the security issues related to the new verticals. So when it comes to the pre-5G security issues, so some of these attacks actually not even a new attack. So these are like the already available in the most of the network. So one of these attack is the mobileware attack, like DDoS, botnets, advanced persistent attack. So these attacks become severe in the 5G domain, because we will have more and more powerful mobile devices, and also there will be like a billions of mobile devices connected with the 5G network. So this is like one of the biggest challenge we need to address. And the physical layer attacks. So the physical layer attacks are the attacks related to the radio access network. Here you can see some of them are like the radio jamming attack, like means somebody can use a jammer to attack the quality of the communication signal between the tower and the receiver. Or even you can do some kind of also there's like a rogue base station can act as a jammer, and it can jam the real signal and transmit another fake signal to representing him as a real base station. So this can be another big issue. And the roaming fraud and IP hijacking. So this is one of the big financially impacting attack, because the people can hijack the IP address while the roaming customers are returning the IP address, and use this IP address to use some data and also do some fraud activities that can cost a lot of money, because for the moment, like detecting this roaming hijacking attack will take at least 20 minutes. So that means quite some time to do some kind of attack. Even though you detect the attack, it will take 20 minutes to mitigate that. And also there's some attacks possible via other network like Wi-Fi, WLAN, or even IoT network, which doesn't have a lot of security in place like the mobile network. So these are not pre-5G, but they become 5G specific, but they are become severe when the 5G network introduced. And then another one is the security impact of the network softwarization. I mentioned like the network softwarization have like a bigger benefit and more benefit like how we can use the network, but it has a lot of security issues. One of the biggest issue we are facing is because network softwarization concept introduced an open architecture. So that means open architecture means it introduced a lot of attackers. Because before that, the telecom network is like a black box. Only very few people know how the network is operating, and that means only very few attackers are available. We call it as the implicit security. But when we have like open architecture, everyone understands how the system is working. It is easy to attack, and there will be a lot of attackers because of this open architecture. And also another problem we are facing is the no perimeter security, because you can see this is how the 4G network look like. Here you can place all your core component inside these 2 racks or 3 racks, and you can provide the physical security around it. Basically, you can make sure the firewalls are there to have the access to these devices, and also maybe you can physically secure this thing with the security guard or something. So you can have like a perimeter security around these devices. But in the cloud environment, we don't have this kind of perimeter security anymore, because your services might be running in far away in a different cloud environment. Having the perimeter security is almost impossible, and this is another big problem we are facing. And also, since we move for this software-based scenario, the virtualized element, so you will be deploying the software application as a control application in the 5G network. So because of the competition, you omit the proper security testing, and you just deploy the services and you upload the patch later. But before that, in the 4G or something, we do a rigorous security testing before we deploy any device or any control element in the core network or in the mobile network. So this is also a big problem. The fast deployment of the virtual element will omit the proper security testing. And then the introduction of these new technologies will introduce a new set of vulnerabilities. For example, like we have this software-defined networking. The idea of software-defined networking is to separate the control plane from the data plane. So when we have like a centralized controller to control the whole IP network. So this is the idea. So when you have like a centralized controller, now it automatically become the honeypot for a lot of attackers, vulnerable for the DDoS attack, the flow modification attack. So that can actually jeopardize the whole SDN-based network. And also we introduce network function virtualization. Again, the idea here is like using the virtualized network function instead of dedicated hardware-based architectures. So in order to run this virtualized network function, we need the hypervisors, virtual machines, and this kind of vulnerabilities comes along with these hypervisors or virtual machines are become a part of 5G network anymore, become a 5G network in long run. Especially there's a virtual machine, there are many attacks like virtual machine escaping attack. If you don't have proper isolation, some of the information can be leaked between the virtual machine if the hypervisor is not properly configured. So it is possible to have denial of service attack. So those kind of issues are arising. And then there's another concept called network slicing. The idea of the network slicing is like we are virtually dividing the network into multiple networks. So you can think it as like a virtual LAN or VLAN scenario, but it's much complicated scenario because we are having this slice all the way from radio access network to the core network. So if you don't do the proper slicing in the network, there will be a security issue. Some of the information can be leaked between the slices because some of the slices have like less security than the other slices. Since you are sharing the same physical resources by multiple slices, the information can be shared, and it can be like a interslice attack. And then we have the multi-access edge computing. So that means like we are trying to bring the cloud computing all the way to the base station, so we can have the faster the cloud access, especially the autonomous driving cars kind of scenarios. You need to process the data already at the base station, not at the cloud. So this is the concept we are bringing with the multi-access edge computing. So you can have the cloud computing already at the base station. So having this kind of multi-access computing have onset of vulnerabilities because the one of the key element who the manage these make services is the cloud orchestrator. The orchestrator can be vulnerable to many attack if you don't configure it properly. And again, the attacks like virtual machine related attack or migration attack become part of the edge computing as well. So you can see like the introduction of these new technologies will introduce a new set of attacks which were not part of the previous generation of mobile network. And existing pre-5G security mechanism definitely not enough to mitigate these attacks. And also then we have these security issues related to the new verticals. That means since I have mentioned the introduction of IoT will allow us to interconnect a lot of new 5G verticals like e-healthcare, autonomous driving cars, smart grid, smart home. So all of these verticals has a different set of security requirement. So here you can see like I have listed some of these things. For example, one of the key benefit of the 5G. So in 5G actually we are categorizing application under a special form. We call them as EEMBB, like enhanced mobile broadband, URLLC, that's ultra reliable low latency communication, MMTC, that means machine machine type communication. So these are the main 5G classes. Under this class, like enhanced mobile broadband, that means you have more bandwidth for the communication, especially it is needed for the streaming, augmented reality or cloud gaming kind of scenario. In these scenarios, actually, the confidentiality, integrity, availability is not so critical. You have to have like a medium level, but sometime in the high end availability, especially for the cloud gaming scenario. Then we have this ultra reliable low latency communication. I think this is the most important factor we bring from the 5G than the 4G network. They are using, this is very important for the autonomous driving cars, remote surgery, or industrial automation kind of scenario. In this case, actually, integrity and availability is really, really important. For example, if you think about the autonomous driving cars, if the cloud services are not available, so the whole operation will be jeopardized and it can lead to um, human casualty as well. So the same for the remote surgery. The communication availability of the communication network very, very high. So that's, you can see the requirement are different from the different use cases we are going to use. And even the machine type communication, it's about like how you can connect like millions or billions of devices. It's available for the IoT or smart sensor kind of scenarios. In these kind of scenarios, availability is not so critical because IoTs are like working in the intermittent fashion. So you can see like the different classes has different requirements. This is why we are introducing this network slicing concept. So we can have different classes running a different slice and we can have the different level of security for each class. So we studied about these attacks and we try to see like understand like how this attacks landscape is going to be changed with the 5G. So we define what are the 5G security requirement when we are developing a 5G network. So we have this ITU, the International Telecommunication Union. So they are defining the security framework which is needed for end-to-end security. So we are proposing a certain level of security we need to have in the different segment. For in the user level, we need to have like malware protection, side channel attack protection, and when we consider about radio access network, the AI interface for security, especially for the radio access, and the MAC and SDN security is needed. When it go to the core network, we have to think more about the cloud related security like SDN and FE security, and the cloud security is playing a bigger role, and also the network slicing. And then the web or the application security is beyond of the 5G network. So the typical the web security scenarios are needed for the application. And also we have to think the beyond current scenarios, especially what kind of cryptographic method we have to use, because we have to think the cryptographic mechanism which are not only secure but also applicable for the requirement, the performance requirement of the 5G network. And also we are looking for this quantum safe cryptography because we are thinking ahead what will happen if the quantum computers come in. So what are the quantum safe cryptographic mechanism we can use in this domain? So the additional security mechanism like security emergency response, security testing and certification, they also define like what kind of things we are going to use here. But I don't have time to discuss all of these things. So they basically I just give an idea like what kind of enablers we need to consider in the 5G domain. So and so far I have discussed only the issues with this network softwarization. Actually, it can also help to have a better security in the 5G as well. So I will go through quickly about like how we can use this network softwarization to improve the security. So one of the area like we can use is like we can have like fast deployment and the update of the security mechanism. So now the security solution are also deployed as a virtual function. You don't need a dedicated hardware anymore. Like you don't need the firewall hardware or you don't need the NAT gateway hardware or anything. So now you can deploy them as a software application, as a virtual application on top of your network. So that's actually help us to have a faster deployment of security solution. Even the update of the firewall is much faster because you are now doing on the software level update, not the hardware level update. And also we can improve the security with the centralized security control because so far in the 4G network, we have the distributed security. So the distributed security is not generally optimized, and also we don't have the global visibility how the network is performing. But in 5G, I have mentioned we are using 4 technologies like SDN, NFV, MEC, and network slicing. All of them supporting the centralized control. So actually, that can help us to have a centrally controllable security over the 5G network. We have the global visibility how the network is performing, so we can have the unified security across the whole network because of this, which was not possible in the 4G network. And the optimization of the security resources and the reduction of the cost. Now we don't need dedicated hardware, so we can time share the network resources with the other services when the security functions. And also we can do the better optimization of the security resources. So we can dynamically scale up the cloud resources which is allocated for the security services. For example, if there's an attack going on, we can allocate more resources to mitigate this attack. You don't have to have like a pre-assigned security resources because you can dynamically add more resources based on the cloud resources. So this is a very nice function. We can properly optimize the security resources and also reduce the cost of deployment of the security services. And also we get that like the new ways of delivering the security, especially like before that, all the security has to be addressed at the device level. But now the network can step in to provide the security, especially for the IoT services. For example, in the factory environment, you don't need to deploy all the security function in the IoT level. You can deploy the security function maybe at the edge of the network using edge computing scenarios. So then you can assume this factory environment is already secure environment, and you have all the security deployed already at the edge. So you can have the cheaper IoT devices and the better security with the the edge computing. So we call it as like a security as a service via edge. So this concept become very popular. And also the network slicing can also help to do the same concept. So we can have like a separate security slice to manage the security instead of uh, having the security in each and every slice in the network. Okay, so I think that's all I want to discuss. I think I covered the what are the security issues and how the network softwarization can help us to improve the security. And if you want to follow us, you can follow our lab in this LinkedIn page. And also there are a few books we have written. Myself and our colleagues has written on this area, especially the software. The first book is about the software-defined networking, like how we can adapt this network softwarization concept to build the 5G network. And the next two books, one is focusing on the 5G security, and the other one is the IoT security. So these books are also very nice if you want to learn more about the 5G security. So since the time limitation, and I think I talk with Inesh also, I give like a very high level idea what is needed. But if somebody wants to discuss more about in-depth uh, discussion, so I'm happy to discuss as well. So thank you.
Thanks, Madhusanka. Lads, but if you have any sort of questions, you can drop all those into the chat. Hope the chat is available. I'll enable the mics as well, so just ping me if you want to speak, so I can disable, so I can enable the mics, which is currently disable mode. We give a few minutes. Do you guys have any questions for the speaker today? In the meantime, I would like to emphasize all ISC2 members and ISACA members, please fill out your CPE form, so that'll be easy for us to capture your CPE credits. All right, if there are no questions, once again, thank you so much, Madhusanka, for the insightful session today about the 5G security, and we'll hope to collaborate with you more and more in terms of the UCD, and with you as well about the telecommunication security, and then what more that we can see in future in terms of the technology evolvement. Thank you once again for the insightful session today, and have a good night, everyone. Thank you so much for joining with us as well. So have a good night.
Okay, thank
Thanks
you.
all.
Bye.